Looks like we have another discovery coming from the James Webb Space Telescope that challenges our understanding of how galaxies evolve and how they seem to grow over time. And that's because for a very long time, we always assumed that galaxies, especially a long time ago, or galaxies far enough back into the early universe, would mostly be young, chaotic, and very likely rapidly spinning. And that's because they would go through a lot of different collisions and overall just be a lot more vigorous than what we observe today. However, a recent study with the new observations from the James Webb discovered something that, once again, nobody expected. A massive galaxy that seems to be not spinning or not rotating at all. It's literally just standing still. And so, hello info person, this is Anton. Let's discuss this new discovery and what scientists believe might be happening here, and of course discuss why this is important. But first, let's discuss why galaxies usually rotate and what this rotation tells us about the galaxy itself. Or essentially, let's discuss the so-called galactic rotation curve. And while the thing is, pretty much most galaxies around us, and the ones that can be generally seen with a typical telescope, rotate in a very orderly fashion. So here we're not just talking about the Milky Way. Any giant galaxy, and especially a disk galaxy, is going to do something like this. And that's because when galaxies just form from various clouds and gas, the influence of gravity and the way gas flows into them sets them spinning in a certain direction. And this overall spin for galaxies is usually measured by something referred to as the rotation curve. For example, here is the rotation curve for the Milky Way. And this essentially shows us the average velocity of stars and gas at a distance away from the center of the galaxy. So on the left side, that's where the central black hole is, and on the right side, that's the edge of the galaxy and various satellite galaxies like the Large and Small Magellanic Clouds. And so essentially this is a plot of speed of stars against their distance from the center. And the thing is, based on orbital dynamics from the solar system, for a very long time astronomers assumed that what we're seeing in the solar system should be kind of similar to a galaxy, but on a much larger scale. So basically just like Mercury moves much faster than planet Earth, because it's much closer to the Sun, something similar should be happening in galaxies. But as the astronomer Vera Rubin discovered, and a lot of additional observations confirmed in the last few decades, that's not the case at all. The stars at the edges of the galaxy actually move just as fast as those in the middle, making the whole galaxy overall spin at a relatively similar velocity. And this led to the eventual realization that galaxies seem to be embedded in a massive halo of what's known as dark matter that provides this extra gravity. And so rotation curves and rotation of galaxies is the primary way we normally measure galactic weights or galactic mass, and of course study the mysterious dark matter, as well as a lot of other things about various galaxies, including their evolution and their history. And so in that sense, galactic rotation curves are actually super important. And though quite a few galaxies seem to have very similar galactic rotation curves, in the last few years we've discussed a few anomalies, usually involving these very bizarre dwarf galaxies, that seem to actually not meet the expectations and either have extremely fast-moving stars, implying they have a lot of dark matter, or actually seem to have rotation curves that are very similar to the typical solar system, implying they have no dark matter. You can learn about both of those examples in some of the videos in the description. But what about a galaxy somewhere out there that literally has no rotation curves? Or essentially, all of the stars appear to have completely stopped. Now, that's an anomaly nobody expected, and that's the anomaly we're discussing today. And so here, the research team led by Ben Forrest from UC Davis, we're looking at a galaxy with the somewhat difficult name XMM Vid1 2075. The galaxy that's kind of far away from us at a redshift of 3.5. And every time I have to convert redshift to an actual distance, I've actually been kind of cheating and using this incredible calculator by Ned Wright from UCLA. And so basically we're talking about a galaxy whose light took approximately 11.9 billion years to reach us, and that's nearly 22.5 billion light years away from us, which is why it looks so super pixelated in this image. But even at this age, when the universe was only about 1.8 billion years old, this galaxy was already a monster. It seems to be ultra-massive. But it's also a quiescent galaxy, implying that it's not producing new stars. And that's despite the fact that it's several times more massive than the Milky Way and should be producing stars at this point. This is basically almost during the cosmic noon when most of the stars in the universe were being produced. But the observations here suggest it almost completely stopped producing stars and basically resembles something like this. But additionally, by using the near-infrared observations, the team was able to do something incredible. In essence, they were able to map the internal movement of the stars within this galaxy, even though it was super far away, and then compare it to some of the other galaxies nearby. And while normally in these red and dead galaxies, at least the ones we know of, you would expect something like this to involve a fast rotating disk that just basically ran out of gas. So essentially it's not producing stars because there's just no more gas left. But instead, they seem to have found a slow rotator. Here the stars aren't orbiting in a coordinated circle and instead seem to be moving very slow in a somewhat random, chaotic path. Or in more scientific terms, this is what's known as a dispersion-dominated system. And though this is something we've seen in, for example, stellar halos or globular clusters, systems that often have a lot of turbulence and a lot of instability, this has never been seen in these super far away galaxies before. Mostly because in such an object, random moving stars would not keep the galaxy from collapsing under its own gravity, and in theory this object should have completely disappeared a long time ago. But more importantly, from the astronomical perspective, this is also bizarre because of the timeline. Current models suggest that becoming a non-rotating galaxy usually takes a very long time. As a matter of fact, in the local universe, we generally see giant elliptical galaxies that seem to have the same dispersion system, but they're normally billions of years older in comparison. And that's because the standard theory suggests that a galaxy starts as a spinning disk and then undergoes multiple mergers with other galaxies. And with each single collision, the introduction of angular momentum either adds up or cancels out certain types of motion and eventually completely removes organized spin, leaving behind a massive blob of stars moving completely randomly. And so technically, it could happen given enough time. But this galaxy is super young. The universe is only 1.8 billion years old, and that's simply not enough time for a galaxy to have gone through a lot of collisions in order to lose its angular momentum. So something here definitely doesn't add up. And especially because a lot of galaxies close to it seem to definitely spin and do contain angular momentum. And so the obvious question is, okay, so what could have possibly happened? And here we have three possible explanations. First, I guess the most obvious one, this might have been the result of some kind of a perfect collision. Instead of many small mergers, this galaxy might have just formed by one massive counter-rotating merger, with two giant spinning galaxies hitting each other while actually spinning in opposite directions. So basically their angular momentums just completely cancelled out. And this would leave a non-rotating remnant that was just formed within the last few millions of years. And though this would be an extremely unusual discovery, here there's possibly even some evidence for this. Some of the images from the James Webb show a kind of a low surface brightness feature, or basically a very faint smudge of light off to one of the sides. And this might be the remains of a recent interaction. In this image you can see this in the top right. Additionally, this could have been the result of a very specific type of gas infall. This is based on a different theory and is supported by certain computer simulations, but here rotation can be removed by gas falling into the galaxy from all directions at once. And so instead of coming from a single direction or from some kind of a stream outside, here this involved some kind of a chaotic inflow that triggered a massive burst of star formation, which produced so many galactic winds that first it ended up shutting down additional star formation, but second potentially destroyed the galactic spin, with all of the stars just remaining in space without any specific motion. In other words, it was just a result of various gas clouds colliding in various spots and suddenly forming stars without any preference in direction. And the third explanation, and potentially the most exciting explanation, is that this is just an extremely rare type of a galaxy. And this is also actually based on simulations that predict a very small number of galaxies that technically can exist and could be extremely rare. In other words, previous simulations predicted the existence of these non-rotating galaxies in the early universe. But exactly what happened here is, of course, not going to be known for quite some time. Overall, though, for astronomy, this is once again a pretty big discovery. It essentially tells us that various mechanisms that transform galaxies from spinning disks into these chaotic blobs seem to be already working efficiently in the extremely early universe. And it also highlights that we still don't really know much about galactic formation and of course dark matter. And so if the current galactic models cannot explain how this developed, especially because this is a very massive galaxy, it means that our models definitely need to be rewritten and require some updates. But the next step for this team, and of course scientists doing similar research, is to now find more similar galaxies, or to find more of these slow rotators, in order to find out if XMM Vid1 2071 is just a strange one, or just some kind of a one-off, or if we've actually been missing a huge part of the cosmic story. And this is potentially much more common than we thought. And so until future discoveries, or until someone else discovers something else about similar galaxies, that's pretty much all we know. We'll definitely come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.